Hello and welcome back to App for You. So in this particular video we'll be discussing the problem wherein we have to put all the negative numbers before the positive numbers, right? So in the previous video we had already discussed two techniques of solving this particular problem. The method one was very basic in nature. So method one was basic, and that basically took time complexity order n, sorry, and space complexity order of n, right? Because we were using extra space. We improved it using method 2, wherein we were using the partitioning technique of quicksort, right? So basically in this particular technique the time complexity was again order of n, but this time we were more memory efficient and we were able to implement it in constant time. So this was basically by using partitioning technique, right, of the quicksort partitioning technique. Now, can we have another approach for solving this particular problem? Now, remember, before we begin, the relaxation that was provided in these two problems were that the relative ordering of the elements is not necessary to be maintained, right? So, basically, the only objective is that they're interested in having the negative numbers towards extreme left and the positive numbers towards extreme right, and they don't bother about the relative position of the elements, right? So, we saw that this element was successful in preserving the relative position, but even though it was not necessary, it's fine. It is taking the space complexity order n. If you consider this particular technique, now obviously the relative position was being disturbed in this particular point, right? But as they again, this problem does not bother about relative position, so it's fine. It was accepted solution because space complexity was order 1. Can we have some more technique of solving this particular problem? Then now in this particular video, we will be coming up with that particular technique of solving this particular problem, wherein the negative numbers will be towards left, positive numbers towards right. Right, now this technique is method 3. So method 3 also can be solved using time complexity of order n only, and in this case also space complexity will be order 1 only, right? So that depends upon your implementation, which one you feel comfortable, but it is good to know that all the techniques. So method 3, how can you basically solve this particular problem using 2 pointers? So this game is all about 2 pointers approach. Now how will it work? Let us see. So first of all, write the problem that we have. Suppose the array elements are -1, 2, -3, 4, 5, 6, -7, 8 and 9. I will have a pointer I towards extreme left and a pointer j towards extreme right? So let me declare accordingly. Integer I is equal to pointing to 0, comma j is pointing to n minus 1. Fine. I will basically moving the pointer I. So okay, so I will basically move pointer I towards right and pointer j towards left. Okay, so this will carry on as long as I is less than equal to j. Fine. Now how will it work? So basically remember, my target is to have negative numbers followed by positive numbers, right? So negative numbers should be here left, followed by positive numbers. So basically if I is pointing to any element which is negative, please pay attention, if I is pointing to any element which is negative, and at that time if j is pointing to any element which is positive, so do you think this is a problem? Obviously there is no problem. Why? Because my condition is says that the negative number should be in the left, the positive number should be in the right, so they are in their correct position. You don't have to bother about this configuration when I is pointing to a negative number and j is pointing to a positive number. So basically I will say if array of I is basically less than 0, and at the same time if array of j is greater than 0, means if array of I is negative and array of j is positive, what should we do? Now basically in this particular case we should proceed I to the next point, because I have confirmed that this is okay, this is in correct position. I have confirmed that this particular element is also in correct position, so I will move towards right, j will move towards left, right? So basically what should I do? I should say if this is the condition, that is if I is negative and j is positive, then just move I towards the next and j towards the left. That's it. Okay, what is the other condition that I can come across? The other condition that I can come across is if both are positive, like in this particular case, if I is also pointing to a positive element, j is also pointing to a positive element. So what is the problem with? So see, there is no problem with this. Okay, there is no problem with j. Why? Because j knows that the element towards right should be positive only, and you can see the element towards right, that is in this right position, is 8, and it is fine. Actually 8 has to be in the right position only because it is positive, so this will confirm that 8 is in its correct position and j will basically move left. So what you are saying, if we find that array of I is basically greater than 0, and at the same time if we find that array of array of j is also greater than 0, means if both are pointing to a positive element, then what is the step to this? The step says that if both are pointing to positive element, then this particular j, which is now at pointing to 8, basically is proving that it is in correct position, because it has to be in the right only, because it is positive. So no problem with it, validate it, and j will move towards left. So we will just perform j minus minus. Fine. But do you think we will perform I plus plus? No, we will not perform I plus plus, because we know that this is in a faulty position, because 2 is not meant to be here. 2 actually should be towards right. Here should be a negative element, right? Because I should basically is waiting for a negative element to come here, right? And j is always meant for positive element. J always expects a positive element to be here, so it's fine. So it got 8 here, it is fine. So j moves forward. Now what is the next condition? So we will not basically increment I. So I remains here, and j now points to -7. So if we come across a condition where I is pointing to a positive element and j is pointing to a negative element, so what should be done? So again we have another statement for that. Else if array of I is basically pointing to a positive element, which means if array of I is greater than 0, and at the same time if we say that array of j is pointing to a negative element, less than 0, so we know that they are actually in their incorrect places, isn't it? You can clearly see, because array of I is positive, pointing to a positive element, and we know that negative element should be here, and j is pointing to a negative element, and we know that a positive element should be here. So why not do one thing? Why not let's swap them? We can swap them, right? So we can just say swap array of I comma array of j. So they will basically swap their position, right? And after swapping, what we can do? I can move next, and j can also come left. Getting the point? So if we perform swapping here, what will happen? This will basically be -7, right? And this will basically be, what was here? We had 4, I think, right? I just forgot what was there. Okay, let's see which element was there. I think 2. Yeah, 2 was there. Fine. So basically they will swap each other's position. -7 will come here and 2 will come here, right? So this is what would happen after swapping. 2 comes here. Now what will be the new position of j and I? So I, which was earlier pointing to this index, will now point to this index. J, which was pointing to this index, will now point to j index, which means that this is in the correct position, and this will prove that this is also in the correct positions. Now I is again pointing to a negative element, j is pointing to a positive element, and we know that if this is the condition, if I is pointing to a positive element, sorry, negative element, and j is pointing to a positive element, so what is the meaning? Meaning is both are in the correct position. Finally just do I plus plus j minus minus, I plus plus j minus minus. So this is also proved that it is also in correct position, this is also in correct position. So basically now I will point to 4, j will point to 5. I will point to 4, j will point to 5. Now this is also positive, this is also positive. So first of all, what will we do? We know that actually j should be pointing to positive, and j is already pointing to positive, so j will validate this and j will come here. And I is actually pointing, should actually be is waiting for negative number, but there is no negative number, and by that time j has already reached this position, right? So there should be a condition. Now you see, we have basically dealt with the condition when I is negative and j is pointing to positive. We dealt with the condition when array of I is positive and j is positive. We dealt with the condition when I is positive and j is negative, right? There is one more condition left, which says that else the condition when both are pointing to negative elements. So suppose -2 and here -3, -5. J is pointing to -5, I is pointing to -2. Now in this particular case, suppose what will happen? Now in this particular case, we know that I should actually point to negative element only, so it is in correct position. It will validate this. So I will move next, so I plus plus. But j actually is expecting a positive number here, so this will not move ahead until it gets a positive number here. Getting the point? So for this particular situation, we'll say else only I plus plus, right? And now you see, by the time it comes here, here both are pointing to 4 only, right? So what would happen here? Array of I is also positive, j is also positive, right? Because it is pointing to 4. And if we know that if both are positive, basically j moves left, So basically j will move left, and next time in the while loop j will no longer be greater than I, right? So basically this will terminate, and we have finally got the arrangement of the array. You can see the negative elements are one side and the positive elements are the on the other side. Now you can also see that the relative position of the elements have been disturbed, they have been changed, right? So let me just clear this particular code. Okay, let me just decrease the size of the screen. Yeah, it's fine. So yeah, this is how we can solve this particular problem using two pointer approach. And if you just try to compile this particular problem, you can see the output. Let's see what is the output, and expecting them to give correct output. Yeah, so we have the output in front of us, that the negative elements have basically appeared before the positive elements, although the relative position have changed, but that is not an issue, because in this particular case they have already said that the relative position need not be maintained, but they want the negative numbers preceding the positive numbers, and that is what we have already achieved. So I hope this video was helpful. You can see the time complexity for this was order of n. Considering the space complexity, it is also constant. Why? Because we have basically used only two pointers to solve this particular problem without using any extra auxiliary space. So yeah, that's all from my side. I hope the video was very helpful. In case of any doubt, please feel free to put your doubt in the comment section. Just like, share and subscribe. Thank you.